Okay, let's just give a minute or two for all of the attendees to join. See they're adding in quite quickly now. So good morning, good afternoon, everybody. My name is Tammy. Welcome to this seminar series on ERDDAP. The seminar series is co-organized, by the Goose OCG Capacity Development Team and the AtlantOS team. So this seminar series will introduce the ERDDAP data services and offer hands-on tutorials and offline guides. It will discuss the benefits both from the data provider and data user perspectives, including lowering the technical barriers to providing and accessing data. Today's seminar is, or webinar, sorry, is one of at least 3 seminars that we will hold over the next 3 months. The next 2 are scheduled for the 12th of October and the 16th of November. So today's webinar will address intro to the ERDDAP, why ERDDAP and what are the benefits, and how to find and use ERDDAP. The future webinars will showcase hands-on sessions on using ERDDAP, how to ERDDAP in terms of configuring data sets and admin questions, and ERDDAP user stories in the context of the UN Decade of the Ocean. After today's session, we will provide a survey to capture specific questions, tutorials, and seminar topics requested from the audience. And I'll share that link within the chat towards the end of the hour. Between the seminars, we will post offline tutorials on the Goose and AtlantOS websites. So please put your questions in the chat and we'll keep an eye on that as we go. Our 2 seminar chairs today are Kevin O'Brien and Callum Rollo. Kevin O'Brien is a senior research scientist at the University of Washington and is a member of the Data Integration Group at NOAA's Pacific Marine Environmental Lab in Seattle, Washington. He is the Vice Chair for Data and Information for the Goose Observations Coordination Group, and he is involved with the WMO as the current chair of the WMO task team on NetCDF and leads the Open Access to GTS project. Callum Rollo is a data scientist at the Voice of the Ocean. Callum is responsible for processing, correcting, standardizing, and distributing scientific data from their fleet of autonomous platforms. He works with other data managers at organizations like SMHI and eModeNet. So Callum holds a PhD from the University of East Anglia in Norwich from the UK and has worked on marine gliders and the integration of acoustic Doppler current profilers or ADCPs. So at this stage, I'm going to hand over to Kevin to begin the series. Thank you.
Thank you, Tammy, and thank you for that introduction. And welcome, everyone. It's great to see so many people here. I'm going to share my screen here. So as Tammy mentioned, we wanted to have this seminar series to kind of introduce people to ERDDAP, what it can do, the benefits of using and serving your data with ERDDAP, but also how to really utilize the services within ERDDAP as a data user to find access and work with the data that's available through ERDDAP servers. So I'm going to give a real quick introduction to ERDDAP, about 10 minutes, maybe not even so much, and I'm going to hand on over to Callum to kind of walk through some tutorials about how to find and use ERDDAP data. So apologies for this introduction. For those of you who may be familiar with ERDDAP already, this might be a little bit of redundancy, but it's okay because we have new folks in the audience, and it'll be quick. So what is ERDDAP? So for those that aren't familiar with ERDDAP, ERDDAP is basically a data broker, which is really designed and developed to help both data providers and data users access and use data. So for data providers, it makes it much easier to share data and metadata to humans and machines because it supports a lot of different standard formats that people and users of the data desire. And for data users, that means you can easily get your data into whatever client you're used to using, whether it's a Python program, whether it's Google Earth, whether it's an Excel spreadsheet, quite easily, regardless of the internal format of the data. And we'll get more into that a little bit later. But to know, good things to know is that it is openly, it's open source software. It's freely available. There's a relatively a robust user and development community that has been built up around ERDDAP. It was originally developed at NOAA's Southwest Fisheries Science Center by a developer named Bob Simons, but that has now been moved as sort of a publicly supported open source software. It's been installed in over 100 organizations, including NOAA, eModeNet, the Ocean Observatory initiatives, and so it's widely used throughout the community. So some of the challenges that we face as data users when we want to use data is that, we may have data that's in different formats. It may be in different services to access that data, whether it's some sort of weird web front end or just an FTP server. It may be, it is most likely not in a format you're used to using. And so for a user to actually use the data, they often have to download the data, maybe transform or reformat that data, which becomes, a software development project. And we really want to improve how users can find the data that we're producing to make it easier for them to use. And so from the provider challenges, you want to support users accessing your data, but they do have all these different needs of how they want to use the data and the formats they want to work in. And you want to support that, but you don't want to have to duplicate data. You want to make sure that you have machine-to-machine services as well as human services so that people can write scripts around the data and make it more scriptable and accessible that way. You may want to aggregate some collections of data into one large collection, but having to do that may be cause lots of resources and lots of time. And sometimes metadata needs to be modified. And if you have thousands of files and you need to modify them, that can really be time consuming and a big burden. So these are some of the providers that are challenges, that ERDDAP tries to solve. So how does it solve it? From a user perspective, what if you wrap these data sources like CSV files or NetCDF files or databases around ERDDAP, that provides a simple uniform way for users to access any of the data that you are providing through this ERDDAP. Things are become uniform, like what the API looks to query that data, what the time words are to use that data. So the users are then abstracted from that storage mechanism of the files. They don't care if it's a netcdf file. All they know is that they have made a request and they got the data they wanted to. This also provides a lot of machine-to-machine services, which are really important in terms of interoperability and very key for interoperability so that people can write scripts and automated processes to access and process data. One of the things that you can do within ERDDAP too is to correct the metadata that the user sees. So you correct it in a configuration of a file rather than the 1,000 different files that configuration may represent. Makes it quite easy to actually correct metadata to ensure that those that are accessing the data are getting data with the proper metadata. So how does this work? So what is ERDDAP? From a user perspective, it's pretty simple. You have your favorite client software. Let's say it's a Python script. You make a request to ERDDAP. You get the data you want back, the subregion, the subset, whatever you've asked for. But from the background, what's really going on there from the data provider perspective is that the user has made this request to ERDDAP, but that request is then processed and filtered through the ERDDAP software to connect to the actual individual data source, whether it's a MySQL database, whether it's a Threads server, whether it's netcdf files. It reformulates that request to support that native format, returns the result to ERDDAP, and then that gets to the user. So from the user perspective, again, you're just asking for the data from the ERDDAP, but from the back end, it can connect to so many of these different data sources and abstract that complication from the user. So acting as this data broker allows ERDDAP to, as I've kind of mentioned, so provide access to many file formats. We can improve the dataset metadata through ERDDAP without having to modify and duplicate or reproduce the original files if necessary. It standardizes the way the format of time is the format of the time data, so that makes it much more uniform and easy to access that way. It's a standard way to request data from any of the data sets within ERDDAP. All these data sets will have the same uniform way to request the data. You can easily provide access to collections of data or individual granules from the same set of files without having to reproduce the data files. And so we don't have to duplicate data to provide these different access methods. One of the interesting thing and the very important things about ERDDAP that it can do is it can also generate discovery metadata on the fly. And this is schema.org compliant metadata, which is something we'll talk about a little bit later, but is used by many of the big data discovery, Google is what I'm trying to say, like Google. So this is what the ERDDAP sort of UI looks like, and it's a little bit intimidating for those that aren't aware of it, but I like to show it because this is how a human can interact with ERDDAP and learn how to kind of build up these queries that can then be moved into scripts, etc. So it has a listing of the data sets here on the left-hand side. The middle is an actual individual data set that the data access form, which allows you to set up the constraints on individual parameters or longitude, latitude, or time to only download and access the subset of data that you're interested in. It does have a way to make graphs that you can look at, quick look at data. And there's lots of other tools in the UI like this one on the bottom right, which tells you if you have data that's updating, daily or hourly, you can sort of keep track of the status on that. You can say, okay, this data should be updated every hour. You can go to this quick page and see that if it's green, it's good. If it's red, there's an issue, you need to look at it. But the UI is somewhat complicated. And that's for the API is also incredibly powerful. And everything that you can do from the UI, you can also do through an API. So you can do an API call to ERDDAP in a URL using the RESTful API to generate a graphic like this one here. Or this is an example of Google dataset search. And when I said earlier about schema.org, if your data is in ERDDAP, it automatically generates the schema.org discovery tags that things like Google dataset search use. So they can go in and harvest this information and put it into their discovery catalog, and then it can be found. So if your data is in a publicly available ERDDAP, and unless you've blocked like harvesting to this data, it will show up in the Google dataset search automatically. So that is a really great thing for ERDDAP to support, because schema.org is kind of complicated, but it's great to be able to support that. This is an example, and this is, Callum will show more of this in his tutorial, but this, is a Jupyter notebook, which is basically a way to use Python in a browser to access data sets through ERDDAP. You can just kind of set the URL, pull the data in, and start plotting it. We'll see some really great examples of that. But also importantly is that the API allows us to build really nice tools on top of ERDDAP that allows users to interact and discover and use the data without having to go through that ERDDAP interface if they don't want to. And so this is an example of all the ocean data that's collected on the GTS is available through an ERDDAP server. We've built a nice application using Plotly and Dash on top of it to access and use the data from a user perspective. So this really nice dashboard that interacts directly with the ERDDAP API. So just in closing up here, excuse me, some of the benefits of ERDDAP, just to emphasize these, is, it's open source. It's available in GitHub. There's an ERDDAP organization for GitHub. To use ERDDAP, it's a much lower technical barrier. We're talking really mostly about dataset configuration and not coding. Excuse me. It sort of acts as a very effective on-the-fly data format translator. So if you don't know NetCDF, but you want to use NetCDF, and all you have is CSV files, you can integrate those into ERDDAP and still be able to get NetCDF files directly out of ERDDAP. So that's a really nice feature. And I think that's important for trying to build capacity in data providers that may not have the technical acumen to use things like NetCDF at this point. And we're using it to federate. ERDDAP can be federated, so it can have distributed nodes that are federated under a single ERDDAP. And this is a big piece of the Observations Coordination Group data strategy in order to use ERDDAP to federate all the data from the different the global networks. And there's a whole lot of other capabilities that ERDDAP can do that we haven't even touched on, like ingesting data directly into ERDDAP, from a sensor into ERDDAP. And we'll try to touch on these on some of the future seminars that we have. So yeah, lastly, just, one thing about ERDDAP, if you have data, you're serving data in a way, consider using ERDDAP in addition to, maybe not necessarily instead of. They can be complementary to other services. If you're looking for a way to serve ERDDAP, this might be a good way for you to go. And so there's some links in here that I will provide the slides to, and we'll make these available, but there's links to the GitHub organization, a past webinar, and some other examples of how to use ERDDAP and ERDDAP functionality. So thank you. That was it for me, and I'm happy to pass it on to Callum or answer questions if there are any at this time. Back to you, Tammy. I'll stop sharing.
Thank you, Kevin. Seeing no questions, I think we can hand it over to Callum at this stage.
Okay. Thanks for the intro, Kevin. So as Kevin mentioned, we're now going to do something a bit more hands-on. So I'm just going to share my screen now. So I'm starting from an ERDDAP. So these are similar to the screenshots Kevin showed earlier. In fact, I think I have the data set he had here. So this is what you're presented with as an ERDDAP user if you've gone to an ERDDAP and you selected a data set, and you get basically a big tick list of options for all of the variables on this data set. So for this global drifters data set, things like sea surface temperature, salinity, drogue metadata. And some of these have sliders so that you can subset by time, or you can subset by longitude and latitude. So you can interact with these, make the data selection that you want. And then down here, we have a big drop-down list with dozens of different formats. So you can generate an HTML table to just view in your browser. You can get various different types of CSV file, netcdf. You can output as a .mat file even, or an Excel. Basically, whatever file format you want, you can generate from this ERDDAP. What I'm going to go through today is how you can use Python scripting to do this in a more automated and repeatable manner. So for that purpose, I've written a series of Jupyter notebooks. These are all within a GitHub repo, which I will post that into the chat in a moment, so that if you want to follow along, you can do. And what these notebooks do is allow us to sort of directly download data from ERDDAP into our Python program. So we're going to walk through this step by step. So as I showed before, you can do this sort of manual query creation where you visit a data set of interest and you make your selection, you get your output type. And then, as well as clicking the download button, there's a button here which says just generate URL. If I switch back to the data set, we see it here. If I click to generate the URL, it will make a very long URL here. And at its core, that is how you interact with ERDDAP. We're going to do a lot of layers of abstraction here, but all of those layers of abstraction you're doing is they are generating these increasingly complex URLs that are then sent to the ERDDAP server. The ERDDAP server interprets that URL and sends you back the data. So it doesn't matter if you're doing it from a web browser, or you've written a program to do it, or you've just been sent that link in an email. As long as you have that correctly formatted URL, ERDDAP will serve back the data that you've requested. So the first thing we're going to do is we're going to break down that ERDDAP URL and just talk through the parts of it. So we have a valid URL here. So I've got a hand raised there. Was that a question, or am I going too fast? I can't see the chat. Tammy?
No, there's nothing in the chat. Oh, wait, there's a Q&A here. As a request to paste a link to the GitHub in the chat.
Can you do that? Or shall I see if I can get it?
Maybe.
Sorry about that. It's been a while since I've done an online demo. I'm just going to pause this share briefly. I'll put that in the chat. There we go. Okay, so if you want to follow along at home, you now can. Feel free to clone that repo, or you can just click on the links and see the notebooks, so you can scroll back and forth through them. So here we have this long ERDDAP URL, and it's broken down into several parts. The first part is just the address of the server. So here we're using a server that I administrate from Voice of the Ocean. They'll have a /ERDDAP at the end, so you know what kind of a server it is. The next thing we specify is the protocol. In this case, it's TableDAP. So TableDAP is for any sort of 2D data that could be represented, for instance, in an Excel spreadsheet, like time series data is TableDAP. Higher dimensional data is managed through the GridApp protocol, which is a bit more complex, and we might touch on that later. For now, we'll focus on TableDAP. Next thing we have is the dataset ID. So every data set on ERDDAP has a unique ID. So there might be several hundreds or even tens of thousands of data sets. As long as you have the correct data set ID, you can access that, and that should stay stable. We then have a dot and the requested file format. In this case, I'm asking for a CSV file. Those are all of the essential arguments to ERDDAP. There are then a couple of optional ones. First, you have a list of variables. If you want only a subset of variables, if you don't specify, it will give you all of them. And then we have some constraints, like latitude, longitude, depth, and time, most commonly, so that you can get ERDDAP to only give you back a subset of data that you're interested in. So just to note that these URLs often have these little % encoded symbols in. So what these are just hexadecimal encodings of punctuation. So if I pass those using URL lib library, all I'm doing here is I'm giving it that URL and it's going to interpret those special symbols. And we see they're just punctuation. So that %2c is just a comma. The %2a is a greater than symbol. So now we can see the slightly more human looking URL where we have the request to our data set, a comma separated list of variables, and then some greater than, less than constraints. So as I said, we can create these URLs manually, or we can get a program to do it for us. The program that we're using today is called ERDDAP. And here's how we use it. So we import the library, and then we're going to, in steps, build up this URL. So we make an instance of the ERDDAP class object. We give it the server, and we give it the protocol. Next, we'll supply it with a dataset ID. We give it some variables and some optional constraints. And then we tell it to generate the download URL. And if you check this, you'll see that it's exactly the same as the URL that we made by hand earlier. So we still get the same URL. So ERDDAP sees it as the same thing. In fact, we can ask for the response back in HTML. And if I then follow this link, it brings me back to this page where I've made this little selection, where I've selected just a small number of variables from the total, and I've asked for a slightly contracted range in latitude and in depth. You can see how these sliders have been set. So you can go back and forth with this. You can take the URL you've generated through Python and then edit it further yourself if you wish. So now we've got to the same place through Python as we did by hand. The advantage of doing it through scripting, however, is that I can then rerun this query. For instance, I can get that same subset of longitude, latitude, and time from multiple data sets from this ERDDAP, or even from multiple different ERDDAPs, as we'll see in one of the later examples. And it makes it a lot easier to run and rerun this query. And the beauty of it is once you've generated that URL, loading that data into Python is just one function. So this has the method toXarray. And if we run that, we then get a data set. So a data set in Xarray is typically the way that we'd represent netCDF structured data. So we see that this data that we've got, we have coordinates, we have variables. These all have metadata. For instance, if I look at the oxygen concentration metadata, I get things like the instrument name, I get the valid range, accuracy, things like this. So we get this very rich data back because, as Kevin said, ERDDAP has very good data labeling and enforcement of metadata standards. And when we can very quickly make a plot. So here I'm just doing a scatter plot of salinity from this data set. And we could further look through all of these variables if we wished. Xarray has some very nice plotting functionality. So ERDDAP likes fetching data in netCDF format. That's what we would normally recommend because it comes with all this metadata. But if you would rather, you can just get a flat table-like structure, like a CSV file. For that, we normally use the pandas program in Python. So if I run e.topandas, I instead get this nice flat table with 900 rows of all of my data. And if I didn't want to do anything else, I could just do dataframe.tocsv, write out a CSV file, continue my analysis in Excel, read it into MATLAB, read it into R, whatever your preferred program is. The the philosophy behind these is not to lock anyone into a particular program. You don't have to use Python. We're trying to keep these data formats as portable as possible. But one thing I wanted to return to is this idea of subsetting and setting constraints. These data sets are very small. This has only 900 lines or so, but some of the data sets on ERDDAP you get are huge. For instance, there's a data set that has all of the Argo floats and all of the profiles they've ever recorded. That's an impractically large data set to download to your computer, especially if you only want one float or if you just want a load of data at one depth level. The nice thing about setting all of these constraints is that ERDDAP does all the hard work of subsetting for you. So if I go back to those constraints and I tighten them up a bit, I'm adding a longitude constraint here, and I'm adding a time constraint, and I then run that same command, e.toPandas. Now I only get 200 or so rows back, rather than the 900 that we had before, because these are just the rows that correspond to those more restrictive measures that I've set. So this is really valuable if you have very large data sets who only want to use a small amount of them. So there are some more references down here to how ERDDAP works and the ERDDAP documentation, which is really nice. I would recommend having a look through that for some more examples. So in this, we've covered sort of generating a query at a known data set, downloading the data. What we're going to cover in the next notebook is how you find those data sets in the first place. So ERDDAP has quite a lot of search functionality on it, which is quite handy. So we can use just a built-in search function. So again, I'm making an instance of this ERDDAP class. And now I'm using the function getSearchURL. So I'm looking for drifter data sets on the OSMC ERDDAP that we saw earlier. So I look for those data sets and I get back the response. Okay, there are 2 data sets from the global drift that have the keyword drifter in. That's the 1-hour data set and the 6-hour data set. I can run similar queries on other ERDDAPs. So this time I'm going to the sensors ERDDAP and looking for anything which has the word ADCP in it. I'll notice it's also a case-insensitive search, which is nice. So you don't need to worry about capitalizing things. So we see that there's quite a lot of data sets with ADCPs. What have we got? We've got something attached to a bridge. We've got a buoy. It looks like we have some gliders here, which presumably have ADCPs mounted on them. And finally, I'm making a query against European data set here. This is the Ifremer ERDDAP, where you can find Argo data. So here we're looking for chlorophyll and CDOM, and it returns, tells us that there's an Argo BGC dataset, which has all of those Argo profiles with chlorophyll and CDOM. So this is quite useful if we have some keywords to search for. We can do a slightly more sophisticated search if we use one particular dataset, which is called all datasets. So if I go back to our ERDDAP, and we see there's 300 or so data sets. The first data set on every ERDDAP is always the same. It's the list of all active data sets on this ERDDAP. If I click on it, I see we have a bunch of useful information. We get the data set ID, we get its extent in longitude, latitude, depth, and time, and we get whether it's either on the TableDAP or the GridApp protocol. So it's everything that we need to see if this data set might be of interest to us. So I'm going to pull that data set. I'm using the gliders.ius ERDDAP. This is where you can get all of the US glider data. So I'll fetch that data set. And here I'm just keeping the more useful columns, like the institution, the extent, and the time. It tells us we've got 1,600 data sets on this server from a variety of institutions covering a large area. And now that I have this table, I can start asking more questions. So for instance, I can just see, okay, which gliders have called in the last 6 hours and given us some new data. So if you're looking at doing some very short-term forecasting, or you're interested in current sea state, these will be the 20 or so data sets that are of most interest to you. You can look for particularly long-lasting data sets if you're interested in more sort of interseasonal cycles. So here I'm just looking for any gliders that were deployed for more than 90 days. And you can combine these queries as well. So here I'm looking for data sets which went to a depth of greater than 150 meters. Note that you'll see that the variable is called altitude, not depth. Because ERDDAP does atmospheric as well as oceanographic data, the depths are always negative. So just bear that in mind. So I'm looking for a maximum altitude that's less than 150 meters. Slightly confusing contortion there. And I'm looking for data sets that are also further north than 70 degrees. So you see there are just 2 gliders that have ventured that far and gone that deep. Yeah. And once I've found something that matches my interests, I can then set that as the dataset ID. So in this case, I'm just pulled this one, this unit 595, and done this to X-array function, and I'm just going to plot I've just plotted the velocity here. I could start making other plots from this glider to see if it has information that are useful to me. So the nice thing about having the search functionality and the subset functionality is that you only need to download the data that's genuinely useful to you. You don't have to pull like several 10 gigabyte model reanalyses just to get a single point from the middle of each run. You can find out if they have an extent that's valuable to you, and then you can get ERDDAP to do the hard work of subsetting the data for you. And okay, I think we've got a little bit more time. So I'm going to show one more notebook. Hopefully this isn't too much information overload. There will still be time for questions at the end. And I just want to briefly talk about gridded datasets and how ERDDAP handles them. So gridded datasets is a little more complex to manage because rather than just being one long time series, you have this multi-dimensional data. So we're going to have a look at some high-res sea surface temperature products from the Coastwatch server. It's been prepared by JPL. So the start is the same. I make my ERDDAP instance, I give it a server. And notice this time the protocol is GridDAP rather than TableDAP. I give it a dataset ID, and an extra argument I have to run is this GridDAP initialize. So GridDAP initialize runs a little service in the background that gets the limits of this data set. It finds what is the extent in longitude, latitude, depth, and time. What are the steps? For instance, is it on a regular grid or an irregular grid? And what are the variables? So I tried downloading this whole data set before. It was far too big for the RAM in my computer. I couldn't really get very far with it. So what we're going to do here is we're going to get ERDDAP to do some of that subsetting for us. So I set a couple of constraints here. I've got I know this is a global data set. So I'm going to set the latitude step and longitude step to 10, so that rather than giving me back the full grid, it just gives me every 10th value in longitude and latitude. And I'll tell it that I only want the analyzed sea surface temperature. I'm not interested in the error or the mask or the sea ice fraction. So I pull that data set and I see we've still got 1,800 lat and 3,600 longitude points. So this is still a 1/100th of a degree data set. And again, because I've pulled it in this X-array format, we get all of the metadata. It tells me that this has come from the MODIS and ASMR satellites. It gives me valid mins and maxes. I will also carry through all of the user-supplied metadata. So things like citation information, acknowledgements, all are embedded in this data. And I'll just do a quick plot of it. I don't know how well this will come through on the recording, but this is a very fine-grained sort of temperature mosaic from, when's that? September? Yeah, yesterday. That was the last time I ran this script. So you get this very up-to-date data from these ERDDAP servers. So it was too much for me to pull this all in at full resolution. But then if we want to zoom in, for instance, on the Gulf Stream, we see there's maybe some interesting structure there. We can then again, work on those constraints. So because gridded data sets are very large, by default, we'll only get the most recent timestamp. So if I look back up to these coordinate dimensions, we see we've got a lot of latitude, a lot of latitude, sorry, a lot of longitude, but only one time slice. It's only given us the most recent time slice from this data. That's its default setting. If we want to get some longer time span, we'll need to tell it that. So I set the time constraints. So I'm going to look between January and May of this year. I tell it's just going to be back one per month. So I've given it a time step of 30 because I know it's a daily product. I specify the extent in longitude and latitude. And this time I make the step of 1 so that we'll get back the full resolution, I think thousandth of a degree data. So this time we get a data set called DS Gulf. Let's have a look at that. So now we have 4 different time steps and a much finer longitude and latitude grid. So here I've just pulled a couple of plots of how the Gulf Stream sort of changes from January through to May. And that's how we use the ERDDAP function. So it's a little more convoluted. You need to work with these constraints. ERDDAP will tell you if your request is too big, you'll get a kind of unsuccessful response. Just work with the constraints, set the spacing if you need to, and only pull down the data that you want. Again, the advantage of this is you're not having to pull a huge data set, which is out of date almost by the time you've opened it. You can just get ERDDAP to slice that last day for you, just the area you want. And this is a kind of request that you could be running every day or every hour, as long as that's not annoying whoever runs the ERDDAP, of course. Please don't overload people's servers. It's quite rude. But it's a lot more efficient on bandwidth, especially if you have a limited connection. I mean, I'm in rural England here. I think we still had dial-up modem a few years ago. I'm not going to be pulling tens of gigabytes down the cables. So let ERDDAP do the hard work. Just pull the parts that you need. And so that was the end of the demo for that. But I'd just like to talk a little bit about the philosophy behind this and why we make these scripts, why we generate these queries in a programmatic way. An advantage of doing this and using ERDDAP in your analysis is that if you have the data kind of acquisition written as part of the script, every time you rerun that script, it fetches the newest data. So if you're really wanting to get the most up-to-date glider data from the US, rather than having to go and manually re-download those files and rerun your analysis and work with different file names, you can have that built into your program. It also means that this script essentially is the data as well. As long as the administrators, the ERDDAP, are keeping those data sets online, you can send your script to one of your coworkers and they can completely recreate the analysis without you needing to send large data sets to them. So it enables this much more collaborative, much more repeatable way of doing this analysis. So that's my brief sales pitch for ERDDAP. And I think we're at 40 minutes past there. So I'm going to stop this share and I think we'll take any questions that you might have.
Thank you very much, Callum. So the 2 questions which we've had in the Q&A so far were linked to the actual GitHub link, which is fine, as well as the sharing of this recording. So the recording for this webinar, as well as the future 2, the one in October and the one in November, they will be loaded up onto the Goose and AtlantOS websites, as well as offline tutorials that can be done by those that are keen. So keep an eye out on the 2 websites, but also any emailing and notifications that'll come through around this seminar series, and we'll be able to share some of that with you. So I don't know at this stage if anybody's got any other questions that haven't yet been answered. You can either place it in the chat or into the Q&A, or raise your hand, and Kevin and Callum can come back to you. I see Samantha, have you got a query?
Hi, yes. Can you hear me?
Yes, we can.
I just first wanted to say that Callum, thank you very much. The demonstration using the Jupyter notebooks was very, very useful as someone who's starting to build those notebooks myself. And then my second point is a question for Kevin. You briefly mentioned that you can kind of see the update status of each data set. I have yet to see that, and I'm not sure where to find that. Is there any way you can share your screen and show me where that is?
Yeah, let me try to do that here. It's on the main page. So let's see. Let me open up the main page. Share my screen. Okay, so thank you for that. So while we're waiting for this to load up, my internet's very slow today. I'm not sure why. I just wanted to say thanks to Callum because that was really great. I always learn new stuff. I've been using ERDDAP for a long time. When I see your presentations, I learn new stuff. So that's really great. Okay, so now you can see the ERDDAP main page, and this is the same page for every main page. If you scroll down, there's a out of date datasets tab link. And that's the one that will show you, if you click on that, that will show you which data sets are out of date. These are out of date because this isn't the server that hosts those, but that's where you see it, and that's all available from the API as well. And so you can use scripts to keep track of that and not have to go to the page as a user, but as a machine say, okay, there's something wrong, and send an email. That's how we use that.
Perfect. Thank you so much, Kevin. And thank you, Callum, again.
Thank you, Samantha. There's one question before we go to Sean in the chat, and I think this is for Callum. For the gridded data, if we are using other languages than Python, do we need to activate a grid option?
So I understand that I think there's one written in R and there's one written in MATLAB for doing programmatic access of this. I believe the R version has a similar functionality for a grid app. This initialization of the grid is mostly just a way for your program to go and fetch those constraints. Because if you make a request that's outside of grid, for instance, if it's, I don't know, a weather analysis over Europe, and you ask for like latitude and longitude points in the US, you'll get back a failed query. So this initialization of the grid just gives you those initial points so that you know not to try and expand your search beyond that. So yeah, I believe the R1 has that built in. Otherwise, you can just go and look on the page for that data set and set those constraints yourself.
Thank you, Callum. Sean, Dolph, would you like to come in?
Yes, thank you, Tim. So thank you all for this presentation. This has been extremely informative, mostly from a user perspective. But I have a question from a ERDDAP host perspective. So, you know, from a user executing these queries and you know, downloading data and subsets and those kinds of things, from a host perspective, how do we measure the analytics of that? Is there a way for us as hosts to see, you know, who's downloading the data, what subsets they're looking at, what formats are the most popular, and these kinds of things? Is there a way, an easy way, I guess, to measure these metrics and analyze these user requests?
Well, I'll take a quick shot at that, Sean. I mean, everything that happens in the ERDDAP through the ERDDAP is logged in its log files, and there's a lot of information about where the request came from, what the request was, the specific request, how much data that asked for, whether it was a successful request. That all exists in the log. As of now, there's no real standard way to pull that information out and display it to an administrator, for example. But I think that it would be relatively straightforward to do, and it would be a great like internship or something for someone that might be looking for some work, and would be very useful for the ERDDAP community. So that information exists, but there's no real standard way right now to easily display and view that.
Right. Yeah, I think that's kind of the problem we're seeing is, yeah, using the log files, we can get an idea of the hits and that kind of thing. But actually looking at, you know, user, I mean, even just generic, you know, user location by country, for example, or what the users are looking for. If a particular subset of data is more popular than another, or a region is more popular than another. From an operations standpoint, then you can also use that data to say, okay, we need to start sampling this region more than others because the need is greater in those regions. That's just one example, but yeah, I think parsing the logs and generating an output with metadata that's valuable, or user metrics that are valuable is the big question. So the generic number of requests and data size is all there, but just kind of taking a deeper dive is kind of the hope or the focus there.
As a quick addendum to this, I've been asking some similar questions. So I've written some scripts for parsing the Apache and Nginx logs, like running IP queries to figure out where people are located, polling to see which is the most popular data set and data type. It doesn't go super deep into the specifics, but it gives a nice overview. If you want, I'm happy to send you those scripts. Just drop me an email.
Okay, excellent. Thank you, Callum. I definitely would. We're kind of just starting off, and so we don't even know what we don't know yet, and so any information is welcome.
Yeah. Oh, and make sure you're preserving your log files. A lot of systems will delete them after like 7 days. I found that out the hard way. So definitely the first thing to do there, keep the logs.
Okay. Yeah, we have the log files, so it's just a matter of parsing them and taking that deeper dive. But thank you both. This has been a really great seminar, so appreciate it.
Thanks, Sean. And I'll just take just a moment just to take advantage of this to say, we're also interested in knowing what people want to learn more about for the future seminar. So this is obviously one topic that might be interesting. And we plan to show some things about administrating and setting up ERDDAPs. In fact, Callum has already put together a video about installing ERDDAP using Docker, and I plan to do one about installing ERDDAP just command line the old-fashioned way. So we're interested in topics that people might want to know more about, so that we can provide more information and in the tutorials coming up for those. So sorry, Tam, I didn't mean to interrupt.
No, it's perfect. I've put the link to the survey into the chat now already. So if anybody wants to start contributing to that exact point, that's great. I think let's quickly answer this one question in the Q&A is how to slice a subset of data and then download it for a long time period, especially for PODAC API-based surveys.
Do you want to? Well, I mean,
I'm not. Are you familiar with that particular data type, Kevin? I don't know PODAC.
Well, the PODAC API. Well, I'm not really sure. Guess what? So Callum showed you how to subset and download data for a long time period, where you can constrain it on the spatial and temporal ranges. But I'm not sure what you mean by especially from the PODAC API-based service. If you would like to unmute and say more about that, that would be great. Whoever that is.
Anonymous attendee, not sure.
Chat. Yeah.
Okay.
Or throw more information into the chat if you can, and we can pick it up there. But
that's perfect. Okay. And then Ikram, do you want to maybe come in? Oh, let me just allow you to talk. Sorry about that. Go ahead.
No, thank you. It's okay for me.
Okay. All right. Thank you. So then Renella's had a question in the Q&A. What if you are interested in loading ERDDAP data into MATLAB? And she says, I know I'm old, but I also only know MATLAB.
No, that's entirely legitimate. I mean, it's one of the reasons why ERDDAP has .mat file as one of its export options. So that's probably one of the simplest ways. If you wanted to, you could dip your toes into something like Python for generating those URLs. For instance, if you have, say, I don't know, there's a query that you want to run against 100 different data sets, you could generate all of those URLs, select the response to be like a .mat, and then just download all of those and load them into MATLAB as you normally would. Or I think MATLAB handles netcdf files like acceptably these days too.
Okay, thank you. So I'm not sure if there's any other questions or a follow-up on the PODAC question in the chat. I'm not too sure. Q&A. It's still that one that's linked at the moment. So we'll give it a minute or two if there's any other queries or if there's anything else, Callum, Kevin, you want to add at this stage.
Yeah, no, I'll just again say, this is an ongoing series and we're really interested in hearing what you might want to learn about. We have some ideas for the next few webinars, maybe answering a specific science question using data from different places to illustrate the federated nature and how that works within an ERDDAP. Configuring, administrating ERDDAP, I'm sure is as a subject some people are interested in, but not necessarily data users, but people like you, Sean, and people that are providing data, so that we're more interested for data providers. There's lots of things we can talk about, so we really would love to get some input from this community about where that information would be helpful.
Samantha, do you want to come back in?
Yes, thank you, Tammy. I had a question in the Q&A. It was just if Callum could send his email address or drop his email address.
Oh, he
So
threw it
Callum
in the
has,
chat there. Yeah.
yeah,
Oh, he threw
Callum's
it.
added it into the webinar chat.
My chat is disabled, so I actually
Oh
I
no.
see messages that you send, Tammy.
Oh, I see what, yes, sure. Let me quickly copy that over.
Okay, thank you so
Callum
much.
placed it into the, you should be able to see it now.
I do see it now.
So okay, perfect. All right. So I think at this stage, if there's no other questions or queries, so Karak has added the PODAC API doesn't have an option to specify lat and long bounding boxes. It will be great if someone can look into it and see how to subset huge gridded satellite data. So I wonder if that helps with the query.
Yeah, I mean that does sort of help. So correct, yeah. So the ERDDAP is completely separate from the PODAC and NASA, and it is just a way to serve data. I don't know what they're using at the PODAC to serve that data, if it's threads or whatever OpenDAP or Hyrax potentially. But if there's an ERDDAP server on that data, then we could actually start doing some of these things that we've shown. So I don't know if there's an ERDDAP server there. That's really a NASA question at this point.
Okay, great. Thank you, Karak, for clearing that up. So yes, so as we've said, there's 2 more webinars coming up in October and November of this year. So please keep an eye out on both the Goose and the AtlantOS websites. We'll also make this recording available through those avenues so that people can go back and have a look and see at the actual webinars themselves, as well as put offline material available to everyone. I will share it again just in case it was missed, is the link to the survey. There it is now, just so we can get some more of your inputs and interest of what is needed out of this community. Fiona's just posted, yes, sure, Sean will add you to the email distribution list. Fiona's posted an idea for a show and tell for future seminar topics is how to find real-time CTE data available on the GTS and compare it with the same sort of data available in other repositories. And she says it would definitely help her in any case. So I don't know if that's a possibility, Evan.
Yeah, that sounds good. That's a great suggestion, Fiona. Thank you, and we'll put that on the list.
Okay, great. So thank you very much, everybody. Please, if there's anything else, let us know, and we'll be in touch soon.
Thank you, Tammy, for moderating. Really appreciate it. And
it's a pleasure. Thank you very much for having me, and enjoy. Thank you very much, everybody.
Cheers, everyone. Thanks for coming.
Bye.